Many times in the lab, even though you'll have stock concentrations that come directly from the manufacturer, sometimes instead you will have a solid, and you need to weigh that out and then dissolve it in whatever solvent you're using. And so a lot of times we know, because we have a protocol in front of us, what the concentration is that we want, and often we'll make a large volume of it. We can usually dictate the volume, or maybe we're limited by the size of the bottle we have. But either or in this situation are known, or what we know what we want is the concentration, and we know what volume we want. So we're assuming those things. Okay, so how do you approach a problem like this? So one thing you've got to remember is that when you're talking about moles, so a mole is the same as, this is the same as moles per liter. Okay, so when we're working with it as just a concentration, it's basically shorthand for moles per liter. And so you need to be able to remember that whenever we have the big M molar, that always equals little m moles per liter. So you have to keep that in mind. So the way to approach this is we know the volume that we want. And since we are working since molar concentration is moles per liter, you can also go ahead and convert that to millimoles per milliliter. If you want to work in milliliter volumes instead, you can do it either or. And what you're going to want to do, let's stick with liters for now. So we said milliliters here, so we need to first convert that into liters. Okay, so hopefully you already know how to do that, but that would be 0.250 liters. So we have 0.250 liters. And then the next thing we want to do is, because we know that concentration we want, in this case, it's 1 mole per, or moles per liter. Okay, and why am I doing it like this? Because that way we can cancel out units. So remember, to cancel out units, one has to be in the top and one has to be in the bottom. Okay, so we can cancel that out. And so so now that gives us moles. And when we're dealing with a solid, our molecular weight is always going to be in grams per mole. Okay, you can always convert those units, milligrams per millimole, et cetera. Those are other ways to do these things. But let's stick with our molecular weight here. Where do we get the molecular weight from anyway? This is sodium chloride. So there's two ways to get it. One is if you have a periodic table, you can just get the molecular weight of sodium and chloride and add them together. That's one way to do it. But generally, when you're working in a lab, you're going to have a stock bottle, and on every label, it will tell you the molecular weight of whatever it is you're working with. So we use the periodic table for sodium chloride, but if you get a complicated molecule, like some type of dye, for example, you're going to want to just take the molecular weight directly off the bottle, because otherwise you're going to be there forever calculating that. And we need to be efficient in the lab. So now the next thing you're going to want to do is you're going to take that molecular weight. Remember, these things work in both sides. So you have 58, or 4. Sorry, I'm slightly dyslexic here. We have 58, I'm just copying it from here, 8.44 grams, and then write it on the bottom per mole. Okay, I'm going to write a 1 there. And so that cancels out. And so all you got to do now is, remember, you can multiply the numerator when you're doing the fraction. This is you can look at it like that over 0. Okay, so or over, sorry, not 0 over 1. We just don't usually write it that way, but that's essentially, and putting this in parentheses because that's how we would do that. And you're just going to multiply that out, and when you do that, you should get an answer of 0. Writing the wrong thing here. You should get an answer of 14. Also, make sure you know how to punch buttons in the calculator, because that's where I make my mistakes. I actually prefer Excel to do these things because I can fix that I can actually see what I'm writing if I accidentally mistype something. 0.61. And notice we have grams left, so that's how many grams we would weigh out. The other thing to note is that how are you now going to make this concentration? So you're going to use your solvent or buffer, whatever of choice, and how are you going to make that solution? Okay, so this is a large. We're not going to make this in a microcentrifuge tube. Okay, we're going to have to make this in something reasonable, like either something. Depends on how accurate we need to be. This could be a volumetric flask if we have the right volume that we're looking for, or we would typically use a graduated cylinder in something like this with a large, where there's room for plus or minus error is not that high. And so remember that this amount, 14 grams, does take up volume, and you have to remember that you're filling, you add in your solid generally first, unless it tells you not to, and you're going to add in your solvent and fill to that 250 milliliter line. You're not going to add 250 milliliters of water because you would have more than 250 milliliters would be your final volume if you did that. Because remember that this takes up volume. Now when you're working with very small, let's say you weighed out like 3 milligrams of a dye and you were going to dissolve that in like 1 mil in a microcentrifuge tube, when the volume is negligible, you don't have to worry about that, but in this case, that will make it inaccurate. So make sure that you always fill to the 250 mark on the graduated cylinder or the volumetric flask, fill it to the mark. You do not want to make it a higher volume, because that's one of the common mistakes I've seen people do in the lab is they fill it with an exact volume of 250 milliliters, and that's not quite correct.